This is the second part of the solution of the challenge we saw last week. We stopped when we found this vulnerability, and today we're gonna see how to trigger and exploit such a bug. We have two global arrays containing the information about our Pokémons. The first one contains the pointers to the structures, while the second one contains their types. We begin the game with just one Pokémon, whose type is 3, and then we can start playing. First of all, we're gonna fill all the available slots by catching some Kakunas. So we're gonna have something like this. At this point, we will wait till we find the Charizard, and we're gonna try to catch it. Since all the slots are taken, we're gonna be asked to release a Pokemon to make some space. We will pick the last Kakuna we caught, so the pointer will be updated to our new structure, but due to the bug we saw, the relative type won't be updated, and this will lead to the type confusion. The type confusion occurs between these two data types. As you can see, the problem is that the artwork for Charizard is bigger than the artwork for Kakuna, and this means that if we're gonna see our structure as a Kakuna while actually it is a Charizard, we're gonna wrongly interpret part of the artwork as the exact name pointer and the inspect function. And since we have control over the artwork through the update artwork function, we can override these pointers with arbitrary values. I'm use this a first time to achieve an info leak, and then a second time to achieve code execution. So our first payload will corrupt the attack name pointer with the address of read inside the PLT plus 2. At this address we're gonna find the address of read inside the GOT, and at this address we're gonna find the real address of read inside the libc. We need this trick that I stole from another write-up for this challenge to manage the fact that our pointer will be dereferenced first time before being passed to the printf function. And then we're gonna keep the inspect function pointing to the actual inspect function. And in this way we're gonna read some bytes from the global offset table, leaking the address of a read from libc. At this point we are able to move to get code execution, but before we have to remember that we set previously the name of Kakuna when we caught it, and that is left untouched when we call update artwork. So we should set this to bin_sh. We're gonna see why in a second. We're gonna use again the update artwork function to overwrite the inspect function pointer, and this time it will point to the system function inside libc, and this will lead to call system bin_sh and getting code execution. Let's see how to implement this exploit. We begin just with the normal setup. Then we need to fill the available slots for a total of 8 walks. Then we keep walking to find the Charizard. We fight it so that its health is less than 21 and we're gonna be able to catch it. And finally we set its new name. Then we're gonna trigger the type confusion by replacing a Kakuna with this new Charizard. We're gonna corrupt the data pointer. We're gonna leak the address from libc. corrupt the function pointer, get code execution, and retrieve the flag. Let's see if this works. Since I didn't opt out the calls to the sleep function, the script gonna take a bit of time to run. So let me just speed up a little bit the video. Here we are searching for our Charizard. And after that we're gonna catch it, it will almost instantly get to code execution because the slow part is before. And here is the flag. As usual, if you wanna get more insight into what's going on, just increase the log level and run again the exploit, so that you're gonna be able to see all the exchange of messages between our process and our script. And that's all for today. See you next time.